All right. Hey, everybody. Today we are talking 5.3 SAS congruence. So, when we started 5.2 with the CPCTC, that was that corresponding parts of congruent triangles are congruent. If you wanted to show that two triangles were congruent, you would have to go through every single angle and every single side on that triangle and match it up with one on the other triangle. Which would be 6 things that you have to show. But that's a lot of things. And there are actually 4 theorems that we're going to talk about this weekend next that allow us to cut down on that list of things you have to show and only show maybe 3 things. So SAS is our first theorem that allows us to do that. And so SAS stands for side angle side congruence theorem. So you're going to have SAS, SSS, ASA, and AAS by the time we're done talking about these 4 theorems. But for today, we're just focusing on this one. Okay, so what do you need to show in order to have side angle side? Well, if we look at our little example down here, we have triangle ABC and DEF. Notice how we've got a pair of matching sides. We have another pair of matching sides. And then we also have a pair of matching angles. This is side angle side, and the way that you can tell that the angle is in the right place is if you kind of highlight or trace along the sides that you have, the included angle, like it says up here, the included angle is the word for that, is the angle that's made with those sides. So you can trace it, and whenever you trace those sides, that should trace the angle that you know something about. If that traces a different angle, or if, let's say you have a different angle and this one that's traced isn't the one that you have matching on the other triangle, well, then you don't have side angle side. So some of the kinds of questions that you'll be asked is you'll get a picture like this, like any of these, and you'll be asked, is there enough information to use SAS to show that these triangles are congruent to each other? So let's try this first one here. All right, so what I would do first, even if they're already marked, I'm going to mark them again, that we've got one pair of sides, and we have another pair of sides, and we have a pair of angles. If I didn't have all of those pieces, I would need to start looking for other things, like maybe some vertical angles or something that I could use to use SAS. But since we're good, we've got all the components we need, let's see if this will work out. I'm going to trace all of the sides that I have information about. And it looks like the angle that I traced is the one that I know. So the angle is in between the two sides. It's like a side and angle sandwich. The angle has to be between the two sides. So since that's the case here, we say yes, we can show that those two triangles are congruent using SAS. All right. Well, then let's move on to the next one. On this one, we've got a pair of congruent sides, another pair of congruent sides, but I don't have any angle information yet. And if that's the case, if nothing's already marked for you, you might have to find another way that you can find some angles that are congruent. And sometimes it's helpful and sometimes it's not. Let's see what happens here. On this one, I see some crossing lines. So that leads me to believe that we've got some vertical angles going on here. All right, so I was able to find another angle. Now let's see if side angle side will work. At this point, you might be okay at, eyeballing it and going, okay, is that angle in between the two sides that I know? But if you weren't sure, just trace along the sides that you know. And nope, this one, it looks like we need this angle, the angle that's in between the two sides, and this angle, not this one. These ones don't help. So on this one, we would say no. And if you were asked why, you might say, oh, we need to have this angle here and this angle here instead. It's not, or you could say that the angle that we have is not in between the two sides, or it's not the included angle. All right, so we have one that's yes so far, one that's no. Let's keep going. We've got another one. On this one, we notice even more stuff going on here, right? We've got, of course, one pair of congruent sides. And then we've got these arrows going on. And if we remember, those arrows tell us that those lines are parallel to each other. And whenever we see parallel lines in proofs with triangles, we should be looking for those parallel line relationships, those angle relationships. Particularly alternate interior angles is going to be useful to us here. So what I personally would do is probably actually looking at this one first. We will get to those parallel lines and those alternate interior angles. But anytime you have a triangle like this and this that share a side here, you're going to have to label that that side is actually the same and it belongs to both triangles. So they're sharing it. It belongs to both. We want to label that, and that actually counts as a pair of sides because it belongs to one triangle and also the other triangle. So you can kind of count that side twice. Okay, so now let's deal with the parallel lines. When I deal with parallel lines, I kind of like to extend the parallel lines a little bit and also extend the transversal so that it looks a little bit more like a picture that we're used to seeing with our parallel line angle relationships. And then, lo and behold, we do have some alternate interior angles going on here. That would be those two. Okay. So now we've got two pairs of sides. We have a pair of angles. We're good to go to see if this is going to be SAS. So again, I would trace the sides that we know. And if I do that, it looks like the angle is in between the two sides that we know here, and it's in between the two sides that we know here. So our answer should be yes, we can use SAS for this one. And if anyone asked you why you could use SAS, you might point out all the things that are congruent here, like this side and this side being congruent to itself, and then this pair of alternate interior angles here. Okay. So you might have noticed with these, there were a few different things that we used and that you guys are going to use again and again and again throughout looking for side angle side and stuff like that. And actually throughout triangle proofs. So some things to look for. We're going to make a little list. The first one that I think you should be looking for is vertical angles. All right, vertical angles. So like when lines cross, when you have a X kind of situation here or here, you should be looking for vertical angles and labeling them in the picture if you if it's not already labeled in the picture for you. All right, the second thing that we should be looking for is shared sides. You're going to end up in a lot of situations like this one where the triangles share a side just like that. So anything that looks like this or like that, you should be labeling that middle side as a shared side between the two triangles. All right, and then the third thing that you're going to be looking for is alternate interior angles. And remember, you can only use alternate interior angles if you have parallel lines. So if there are not parallel lines already in the picture or in the proof or something like that, then you might not want to think about this one too much. Only if there's parallel lines can you use this one. Just like only if there's crossing lines, you can use vertical angles. So be looking for these different things as you go through triangle proofs now. Because that's what we're about to do, our first triangle proof for the day. Okay, so triangle proofs start off just like any other proof. You start with the givens. But what I personally like to do with triangle proofs, even more important than in other kinds of proofs, I know we've talked about this in the past, but labeling the drawing. If you're not already in the habit of labeling your picture, get in the habit of that for triangles. It's going to help a lot. So here we go. We have one given, PQ is congruent to RS. And even if it's already labeled, I like to go back over it. And then we have angle PQS congruent to angle RSQ. So that would be those ones. And those are our only givens. So this is the part where I want to look at my list of things to look for and look at my picture and figure out, is there anything else I can label here? In this case, there is. We have a shared side situation going on here. So I'm going to label that as well. All right. And we should already kind of be getting an idea of which triangle congruence theorem we're going to use just by looking at the picture. I know we've only learned SAS so far, so your options are really limited for today. But in the future, we'll learn other triangle congruence theorems. And so when you label your picture and start looking at it for today, you should be able to see that this is going to be side angle side. We have two sides here, and we have the angle that's in between them. So that should be kind of where our thoughts are going next. But now we want to start our proof. So we start with our givens, and those were already listed for us. So we've got PQ congruent to RS and angle PQS congruent to angle RSQ. All right, so we started with our given. And then just like with any other proof, you're also going to take the part that you're trying to prove and put that as your last step. Triangle PQS congruent to triangle RSQ. And that, your final reason, the really nice thing with triangle proofs, your final reason is always going to be one of your triangle congruence theorems. So in this case, since we only know one of them, it's going to be SAS every single time today. All right. That just leaves us one more step here in the middle. And if you look back at your drawing, we might notice there's only one thing we haven't addressed so far. We already got our givens. We haven't talked about this one in the body of our proof yet, though. And so here's how you refer to a shared side in a triangle proof. You take QS is the side that it is. You say QS is congruent to QS. And it seems kind of silly, but you have to acknowledge that it belongs to both triangles, and this is how we have chosen to do that. And this actually probably looks somewhat familiar from a couple chapters ago, chapter 2, when we talked about a couple different properties of congruence. We had reflexive, symmetric, and transitive, right? And this one is an example of the reflexive property of congruence because it's the same thing on both sides of the congruent symbol. So reflexive property of congruence, you can just abbreviate POC as we usually do. And there we go. The proof is done. We're all good. This one, reflexive property and something being congruent to itself, is going to come up a lot in triangle proofs because we have a lot of shared sides usually when we talk about these. So that's a good one to keep tucked away for the future. Okay. So let's kind of go back and recap our process real quick. So that, when you're doing one of these later, you can go back and kind of follow what we did. So triangle proofs. Here we go. Step 1 was to label the drawing or label the picture with everything you know. Even if it's not in the given, if it's something you know from your things to look for, label. All right, that's step 1. Step 2, start with your given, just like with any other proof. All right. And then the nice thing in these proofs, I would jump right to the end, and your last reason is, for this class, it's always going to be SAS, SSS, ASA, or AAS. We might get to HL, but we'll cross that bridge when we get there. That's one more that we might use for right triangles. And like I said, for today, SAS is the only one that you need. Tomorrow we'll talk just a little bit about SSS and get more in depth with that later in the week. But anyways, and then finally, so once you've got the beginning, you've got the end, now we need to fill in the middle. And this is where you put all of that stuff that you wrote in your picture, but haven't yet addressed in the proof. So fill in the middle with anything from the picture that hasn't been talked about in the proof yet. All right. And so that's kind of our introduction to triangle proofs here. Your homework is on the next couple of pages here, and I'll post along with the notes what exactly the problems are for that. If you have any questions, feel free to email, comment, contact me in any other way, and I can help answer your questions. Otherwise, have a wonderful day. Good luck with your proofs. You got this.